Hello my friends! Alright, are you ready for that last tutorial of the hierarchical clustering implementation? Here we go, we now have the dendrogram which gave us the optimal number of clusters, which turned out to be 5, and so now we're going to build, train and run the hierarchical clustering to indeed identify 5 clusters. Alright, so let's do this. Let's create a new code cell here to build, train and run this hierarchical clustering model. Alright, so remember to build our dendrogram, we actually used the SciPy library because it contained this dendrogram function which directly returned the dendrogram which was perfect. But now, in order to build the hierarchical clustering model with 5 clusters, well, we're going to go back to our best friend scikit-learn, because indeed scikit-learn contains, if you remember, the cluster module which contains the agglomerative clustering class, which is exactly, the classic version of hierarchical clustering, the one that you studied in the intuition lectures. Alright, so we're going to start from scikit-learn. There we go, from which we're going to get access to cluster, the cluster module, from which we're going to import that agglomerative clustering class. Perfect, thank you so much, Google Colab. Alright, now the next natural step, as usual, as most of the time, is to create an object or an instance of this class. And we're going to call it HC, because this object will be nothing else than the hierarchical clustering model itself, with all its algorithm inside. So HC, and therefore now we're going to call that class to indeed create an instance of this class, and then adding some parentheses, and now let's see what we have to input. Alright, so can you guess the first parameter? It's pretty obvious, it's actually the same as in the k-means class. The first parameter is the number of clusters we want to identify in our dataset. And we know that it's 5, but I'm very curious about that 3, that number 3 as the other option of the optimal number of clusters. So we'll try that at the end, we will see what we get. But let's start first with n clusters equals 5. Alright, 5 clusters. And now we need to add 2 more arguments. The second one is affinity, which is simply the type of distance that will be computed in order to measure the variance within your clusters, because then you're going to see that we will use again this ward method which corresponds to the minimization of the variance within your clusters. So for affinity here we're going to choose, well, the Euclidean distance, and that last parameter that we need to add is of course that method, but this time the name of the parameter is not method, it is directly linkage. Alright, and so linkage here should be equal, there are several options, but the one we recommend is the ward method, which corresponds to the minimum variance method. Alright, and that's it. So now we have our hierarchical clustering model, but of course it is not yet trained or fitted to the dataset, and so that's exactly our next step here. But remember that at the same time we want to create this dependent variable which contains for each customer the future class they will belong to, the future cluster they will belong to. And therefore, instead of only using the fit method, which usually trains your machine learning models on your dataset, well, we're going to use the fit predict method, which will not only train your hierarchical clustering model on your dataset, but also will create at the same time this dependent variable containing for each of the customers the cluster they belong to. Alright, and speaking of this future created dependent variable, well, we're going to introduce here a new variable which we're going to call y_hc, and this is exactly, that dependent variable you see here with the 5 clusters. Alright, so yhc, and let's go back, that yhc variable, well, will be equal to what is returned by this fit predict method, not only training the hierarchical clustering model on the dataset, but also returning the clusters to which each customer belongs to. Alright, and therefore what we have to do here is just take our HC object, because that's from this object that we have to call this fit_predict method. And inside we of course input x. Just x, right? Because we just need to connect, we just need to fit our HC object, or hierarchical clustering model, to the dataset, which is exactly X, but only, remember, containing the two last features, the annual income and the spending score. All right, so exactly the same as with k-means. Okay, and that's it. Once again, thanks to our best friend scikit-learn, well, in only 3 lines of code, we build, train, and run the hierarchical clustering model to identify 5 clusters. So let's do this. Let's run this cell, and done. We have our model, and it is already trained. So now let's actually do a little print to see, that created dependent variable YHC. And let's play the cell, and we'll see what we get. All right, so remember that the cluster numbers don't go from 1 to 5, but from 0 to 4, because indexes in Python start from 0. So let's see, let's open this again. What these numbers mean is that, well, the first customer ID number 1, belongs to the last cluster, cluster number 5. Then the second customer belongs to cluster number 4. Third customer belongs to cluster number 5, or cluster of index 4 as you want. Then customer ID number 4 belongs to cluster number 4. All right, so this is how you should read it. And the last customer in this data set, the customer actually number 200, this one of age 30 and earning a high salary and spending a lot actually in the mall, belongs to the third cluster, or cluster of index 2. All right, so that's how you should read it. And now let's visualize the final clusters, now that we have this dependent variable that we just created through the hierarchical clustering process. And so there you go. I'm going to close this. We're going to run that cell to indeed find actually, the same clusters as with k-means. With, remember, this cluster representing the customers that earn a low salary and don't spend much in the mall, and therefore we should just not target them too much because we want to be socially responsible and don't push them to consume too much, right? However, this cluster is the cluster of the customers having a high annual income but a low spending score, and therefore we want to target these customers to offer them some more attractive deals in order to incentivize them to spend more in the mall, because otherwise the mall is missing out. Then this cluster is the cluster of customers having a low annual income but a high spending score, and therefore with these customers, you want to be the maximum socially responsible and maybe protect them from spending too much and potentially more than they could afford. So to these customers, we, for example, want to reduce any kind of advertising. Then we have this cluster, which is the best cluster, the one we want to target the most, because it is the cluster of the customers having a high annual income and at the same time spending a lot. So we definitely want to target these customers to, offer them the new products, the new deals, because we know that we have a high chance to have a high conversion rates with them. All right. And then we have this cluster, which is the average cluster, average annual income and average spending score. And for this cluster, well, we don't have much specific to do. All right. So these are the same 5 clusters as with k-means, but now I'm very curious to see what we get with 3 clusters, and therefore what we're going to do is try now n clusters equal 3 here, but then be careful, we need to actually remove 2 lines here when visualizing the clusters, because each scatter plot here corresponds to 1 cluster, and therefore now, since we're about to have 3 clusters, well, we need to remove 2 clusters here. So we're going to remove cluster 4 and cluster 5. All right, and therefore we're just going to end up with cluster 1, cluster 2, and cluster 3 of colors red, blue, and green. All right, so let's just run this again. We can leave the previous cells and just rerun this one to indeed get a new hierarchical clustering model, this time identifying 3 clusters. We can print this again in order to get the new dependent variable with this time indeed 3 clusters, the cluster of index 0, which seems to contain most of the first customers, then the cluster of index 1, the second cluster, and the cluster of index 2, the third cluster. Okay, and now I'm really curious to see what we get when visualizing the cluster. So here we go. We just have to play this cell again, and let's see what we get. All right, okay, so yeah, really 5 clusters was actually a better number, because here with 3 clusters, well, the model just put all these customers, actually the low income customers with both a low spending score or high spending score into a same cluster, also taking the average one. And then we have these two other clusters, the high spending score with the high annual income and the low spending score with the high annual income. And these still actually make some sense, because remember that the clusters of customers that we really want to target after all are this one and this one. And this, is something we don't really want to target, but maybe protect, as per our social responsibility. So this actually still makes kind of sense. And we indeed end up with the same focus of targeting these two important customers that can boost indeed the sales. All right, so that was very interesting. I didn't expect actually to show you the result with 3 clusters. I was just curious to see, and that's very interesting because indeed we end up with kind of the same final marketing decisions of targeting our customers. All right, so I hope you enjoyed clustering, and I hope you are convinced that indeed you should have these 2 clustering models, k-means and hierarchical clustering, because indeed by trying the 2 you can get some extra insights, which is exactly what happened here when building hierarchical clustering, with which we got this extra insight of trying the model with 3 clusters. And so if by any chance you're wondering which model should I choose between k-means and hierarchical clustering, well, just run the 2, it would just take a few minutes, and let's see if you get the same optimal number of clusters. And if not, well, you can try the 2 options. If you get 2 optimal numbers of clusters between which you hesitate, you try the 2, and then you get the final insights to help you make the right decision in the end. All right, so good for clustering. Now we're going to move on to the next part 5 on association rule learning. It's going to be pretty exciting. We're going to work on 2 new models, a priori and ECLA. And so I will either meet you in this next part, or if you want to learn R as well, I will meet you in the next section to build the hierarchical clustering model in R. And either way, I look forward to building another model with you. And until then, enjoy machine learning.